Good morning. Nice to meet you again. I am Sameha2020, chemistry teacher at STEM Alex School. Today we will continue our LO12 for grade 10. Our concept will be VESPR Theory. This means that valence shell electron pair repulsion. That help us to know the shapes of molecules. As we know that electrons want to be as far away from each other as possible since they are all negative. So, we'll talk about shape, angle, polarity, and hybridization in covalent molecule. How can I know the polarity? Yes, by looking at the shape. What about hybridization? It means mixed orbitals. We know that we have s orbital, p orbital, and d. Yes, mixing with these orbitals and each other give hybridization. Our first example is beryllium difluoride. We know the atomic number of beryllium is 4. It has only 2 electrons in the outermost energy level, and also the fluorine atom has 7 electrons in its outer energy level. Yes, we had to find the sum of electrons, 2 from beryllium plus 2 fluorine atom each has 7 electrons. Yes, they equal 16 electrons. So, we make 2 bonds with 4 electrons. So, the remainder will be 12. So, we give each fluorine atom its 6 electrons as it bonded by the 7th one. So, we have 0 electrons. Yes? Can you draw this structure? It's easy to draw it. Now, we have 2 bond pair and 0 lone pairs. Yes? Its shape will be linear. To be far away from each other as it can. Yes, the angle become 180. What about hybridization? Means mixed orbitals as we said before. We have 1 s orbital and 3 p's, also 5 d's. In our example, we have 2 groups. So, the hybridization become sp hybridized. Finally, is this molecule polar or not? Referring to the lone pair of electrons. We don't have any lone pair, so it's non-polar molecule. The second example is sulfur dioxide, SO2, where sulfur atom has 6 electrons in its outermost energy level. And the 2 oxygen atoms, each of them has also 6 electrons in outermost energy levels. So, the total number of electrons become 18. When I make 2 bonds between sulfur atom and each oxygen atom, I consume 4 electrons. So, the remainder become 14 electrons. Then, I distribute them, giving each oxygen atom its own 6 electrons. So, there will be excess 2 electrons remains on the sulfur atom, as it is the central atom in the form of lone pair. Yes, can you draw Lewis dot structure for this molecule? We conclude that sulfur dioxide molecule has 2 bond pair and 1 lone pair. So, it takes the bent shape due to presence of 1 lone pair that repel each of the 2 bonds, making bond angle become less than 120 degrees. What about hybridization? We have 3 groups, 2 bond pair and 1 lone pair, so it becomes sp2 hybridization. Yes, it also polar molecule due to presence of lone pair. The third example is water, H2O, where oxygen is the central atom that has 6 electrons in its outermost energy level, And the two hydrogen atoms, each of them has also only one electron, so the total number of electrons become 8. Then, by making two bonds between oxygen and each hydrogen atom, consuming 4 electrons, so the remainder become 4. If I put these 4 electrons on atom, as it is the central atom, in the form of lone pair, I have 2 lone pair. Yes, can you represent Lewis dot structure for water molecule? We conclude that water molecule has 2 bond pairs and 2 lone pairs, so it takes the bent shape. These 2 lone pairs repel each other and also repel the 2 bonds, making the bond angle effectively less than 109.5 degrees. What about hybridization? Yes, it becomes sp3 hybridized, as we have 4 groups, 2 bond pairs and 2 lone pairs. This molecule is a polar molecule. Do you know why? Yes, due to presence of 2 lone pairs of electrons. The last example is ammonia molecule, NH3, where nitrogen atom is the central atom that have 5 electrons in its outermost energy level, and 3 hydrogen atoms each contain 1 electron in its outermost energy level. So the total number of electrons become 8. By bonding the 3 hydrogen atoms to nitrogen, we consume 6 electrons. So there will be excess 2 electrons. I represent them on nitrogen atom in the form of 1 lone pair. Yes, can you draw Lewis structure for this ammonia molecule? We conclude that ammonia molecule contains 3 bond pair and 1 lone pair. So this molecule takes the shape of trigonal pyramidal. What about the angle? Yes, the presence of lone pair that make a strong repulsion force with the 3 bonds, the angle become less than 109. As we have 4 groups, 3 bond pair and 1 lone pair, the hybridization become sp3. What about the polarity of this molecule? Of course, ammonia molecule is polar due to presence of lone pair of electrons. Finally, I want you to predict the following. What about phosphorus pentachloride? What's the shape? What about the bond angle, hybridization, and its polarity? Can you predict about sulfur tetrafluoride, its shape, bond angle, hybridization, and its polarity? At the end of our session, I want you to get more information. So, go to Active Chemistry, Chapter 5, Section 2, and try to answer the quiz in your TM page.